Most high-speed railways stay as close to the ground as possible. This one did the exact opposite. Instead of following the landscape, engineers lifted an entire 350-kilometer-per-hour railway high into the sky. But why? Was it to make the trains faster? To save money? Or was there something on the ground so difficult that building above it became the only option? The answer isn't what most people think. And once you understand it, you'll never look at this railway the same way again. At first glance, this doesn't make any sense. Elevated railways are incredibly expensive. Every support column must carry thousands of tons. Every concrete span has to be manufactured, transported, lifted, and aligned with millimeter precision. Building hundreds of miles like this costs billions more than laying tracks directly on the ground. So why would any engineer willingly choose the harder solution? Because the real challenge wasn't building a railway. The real challenge was building one across a landscape that refused to cooperate. Along this route, engineers faced crowded cities, unstable soil, rivers, mountains, active earthquake zones, and thousands of properties that couldn't simply be moved. Every mile introduced a new obstacle, and solving one problem often created another. But among all those challenges, one engineering decision changed the entire project.
Lift pressure stable. Securing pins are ready.
Keep it steady. Up, slowly. Hook attached, clear to lift. Watch the balance, moving it out now. Line it up with the guides. Right, steady now. Hand me the 3/4 inch. Got it, it's flush. Keep it steady. Down a little more. Okay, lock it in now. Looks good, start bracing it.
Keep it flowing steadily.
More vibration on the left, check that edge. Looks good, finishing up here.
Drone is clear, resuming inspection.
That decision was to build much of the railway on massive elevated viaducts. Not because higher is better, but because it was the only practical way to keep a 350 kilometers per hour railway fast, safe, and reliable while crossing one of the most complex construction corridors in Southeast Asia. By lifting the railway above roads, rivers, neighborhoods, and uneven ground, engineers reduced sharp curves, minimized level crossings, avoided countless land conflicts, and created a straighter, more stable route for trains traveling at extraordinary speeds. But that solution came with a completely different set of engineering problems. How do you build thousands of massive bridge columns with millimeter accuracy? How do you launch enormous concrete segments across valleys and highways? And how do you make sure the entire structure can withstand earthquakes while trains race across it at nearly 220 miles per hour? Those answers are even more impressive than the railway itself.
Lower it down now. The alignment looks good. Confirming readings now. Let's double check the span measurement. Elevation looks correct. Cross-check the prism. Alignment is spot on.
Keep it steady. Watch the alignment on the template. 2 centimeters to the left. Slow push. Readings are within tolerance. Continue installation.
Check the alignment on this one. Adjusting now. Perfect. Mark it as clear for the next section.
Over the next few minutes, we'll take you inside every stage of this incredible mega project, from the first survey stakes to the final high-speed test run, and reveal the engineering innovations that made Southeast Asia's most ambitious high-speed railway a reality. If you enjoy seeing how the world's biggest engineering challenges are solved, you're in the right
Ensure the
place.
curing compound
Let's
is
get
applied
started.
evenly across the surface. Looks good, no defects. Mark that span as complete. Yes, we are on schedule for the next section. The alignment data is perfect within tolerances.
Everything looks green. We can sign off on this section.
Inspection confirmed. "42, Mark. Mark. Move forward, 55. 55, Roger. Line it up perfectly. Okay, lowering it now. Watch the torque. Looks solid, move to the next one. Turunkan perlahan, tali tegangan. Sekarang putar sedikit. Pas, turunkan. Kencangkan baut itu. Selesai.